Let's scan the QR code and let me check. By the way, have you guys created a Google account for Google Education account? Because I think starting from next week, I will maybe if I have some assignment, I will put some assignment on the Google Classroom. And to access the Google Classroom, you need to have the Google Education account. Okay. So if you have, maybe after this lesson, maybe in maybe tonight, I will set the link for you so that you try to join the Google Classroom. Okay. Okay. All right. I hope you already scanned all this QR code. Okay, let me start with the small quiz yesterday. So most of you are getting the correct answer, which is A, B true, and C, D are false. So the first one, two rational numbers, okay, they always give rational numbers if you plus those two, right? If you have E plus pi, it's of course to pi is 3 point something, E is 2 point something, and it will be a number, right? Okay. And then the square root of 2 is part of irrational numbers. Look at number C first. Okay, irrational number is a set of numbers that is not making sense. Of course, it's not that exact definitions, right? So the exact definition for irrational numbers, if you have irrational numbers, oh sorry, this is irrational. Okay. Rational is a fraction, like 2/3, no, 2/5, 4/5, and so on. Okay, so you have rational and you have irrational. Irrational is something that you have the decimals, but you are not really sure the fractions how will it be, right? And square root of 2, if you type in a calculator, the decimals is endless, right? So that's one definition for irrational numbers. So square root of 2 is one of the example of irrational numbers. And integers, why it's wrong? So you have first is you have natural numbers, which is start from 1, 2, 3. This is natural numbers, and then you have the integer, which is start from the negative, all the negative, and then 0 and 1, 2, 3. And you need to start with without any decimals or fraction in this integers, right? Okay, that's it. And then the other question is sum of two irrational numbers always give an irrational number. Yeah, that's what I mentioned before. So if you have pi plus pi, it's 2 pi. It's irrational, right? But if you minus this, you get 0, which is not a irrational number, right? So of course this is false. Okay. All right. Okay. I will give you some example on, because we already discussed about the equations, precisely the quadratic. Let me give you some examples. Maybe start with something that I think quite easy. So you have x squared plus 5x equal 24. Find all real solutions. So now, because we already know from the number, okay, from the number we have the natural number, the integers, the rational, irrational, and then we have the real numbers. Okay, we also have the complex, but we are in this real numbers realm, right? So whenever you find a question that asking for a solutions, usually in general, they will ask to find the real solution. Okay, but sometimes they will also ask the complex one. But sometimes, and in some cases, but mostly in general, they will ask the how to find the real solution from the equations. Okay, so this is how you find, or usually you need to find the I need to get you into why we need to find the x, okay, and why it's called x, right? Anyone have any idea why? So this is part of algebra. So algebra or algebraic expressions is something like a puzzle, right? If you imagine a puzzle, like a maze, you have yes, blessing, correct. But let me get you in here first. So like if you're finding the path, right? So finding the x in an equation and like in a formula, it's like finding a path. You can have many ways and how to deal with it, especially in algebra. So x is the unknown, right? And why it's using x, not y, not z, not a. Anyone know why you need to have x? Anyone have, like, maybe when you are in elementary or maybe a junior high, maybe you've been thinking it's x, but why you need to write x? Why not any letter? Because basically x meaning is literally it can be anything. So it's actually from the Arabic letters. I'm not sure how about the years, but it's from Arabic letters. It's a shin. So when it's translated to Latin, in Latin they don't have this kind of pronunciation. So this meaning is called shai. It literally meaning anything, and in Latin they don't have this word, so they pronounce it like sh, and then it's become x. So it's become x. Just a trivials for your information, because I was I was found this findings a few years ago, like in, I think, in one of the TED talk, and yeah. So basically, why it's called X? Because the Latins, they cannot pronounce this. Basically this, and now because already centuries passed, and we already in our mind, okay, when you have mathematical expressions, algebra expressions, find real solutions, what you need to find is finding the x. What is x in numbers, right? Okay, let's get back to this simple question here. All right, so what you can do is, of course, you can factorize like we did yesterday, and I've shown several form of the factors. So first is you need to make it in one long formula like this, so the right side becomes 0. So what this equation means is you can have any x some x or a few x that when you plug in into these equations, that will result 0. So sometimes we call this x also as zeros. So any numbers that make all the equation equal to 0. And it's not only one. It can be 2, it can be 3, it can be 4. It depends on the equations, right? Okay, now, because I think this is just a simple quadratic of functions, that you can try and make some trial, right? So how to make 24? You can have 8, 3, either way, right? Or this. But you need to add this to make +5, right? So probably this is better way. So you have x plus 8 and x minus 3. Okay, so it's still not finished yet. You need to solve this. And sometimes you make mistake and making, oh, this x is 8 and this x is 3. Okay, careful. It's equal 0 means first is this, so you have this and you have this. Oh yeah, by the way, sometimes some teachers writing x like this, or some are writing like this, like a mu, but it's actually x. But that's just how to write. But for me, all the same, as long as it's the same purpose and the same method. I think the same. Okay, so you have this. Okay, this answer. So you have two real solutions. Okay, x equal 8 and x equal 3. Okay, move on. If you have this, what's the solutions? Solutions are, any idea here? Anyway, if you feel you need help for create the Google account, let me know. Or I think some of you already have the Google account. So why you need the Google account first? It's helping me to check in all of you into the Google Classroom. So this is for Google Classroom, because it need the NTUST credentials, because Google Classroom need to have education credentials for it. And then the Google account also helped me for the link or the Google Meet. Because if you're using the Gmail or ordinary Gmail and you click the Google Meet, you need to have to wait for my permission, right? And I need to click yes, yes, admit. And it's quite annoying, because I need to accept you to get permitted into the class. But if you have the Google account, you can go into the Google Meet easily without any permission from me. I think several of you already use now, so that's quite helpful. So I think you need to make the Google account as soon as possible. Okay. For next week, it's mandatory. Okay, because I will have some, I think some assignments there, but it's next week. Okay, but you need to try to make this week. Okay, so for other courses also, calculus, basic math. I think just calculus and basic math for me. Okay. All right. So what's the solution here? If you want to type in the square root in the chat box, you need to write. Usually, if you type, you need to write square root like that, and then type in the number. It means it's okay. If you do some some coding, programming, or using any mathematical written notations in certain applications, this is how you write the square root. Like when you write the 2 with this, means 2, 2. But it depends on what you are working on, okay? So, of course, if you see here, let me just erase this part. If you see here, because it already x minus 4 and then squared. So what we need to do is just square root of both of this, right? So we have x minus 4 and then plus minus Yeah, you can also make it expand, make the expansion here. But for what? Again, every steps in math, you need to ask yourself, if you do this, why we need to do that? If you do that, and what will happen? You need to think careful, step by step. Actually, that's part of math. You need to find a way, but you need to question yourself why you need to find that way, why you need to go there. Okay, and every time you practice, you are not just only practicing solving the problems. You are actually practice yourself to make a path, to make a step, 1 step, 2 step, 3 step. And the more you are familiar with math, hopefully you can make those steps clearly and easily to be understood. Okay, and sometimes it will be more efficient. Okay, because sometimes some students, they are solving the problem and they going circle and they don't have any solutions. Okay, yes, using ABC formula, it can help, but like I said, why you need ABC formula? Why you need to find ABC formula? Can you see the answer from here? That okay. Why? Why? Yes. Yeah, you can use ABC formula, but I don't want to use it. Okay. You find the steps easier than ABC formula or not? You are not really calculating anything here. You're just squaring, square root both of the sides, and then just put 4 to other sides, and then you get 4 plus square root of 5 and 4 minus square root of 5. Okay. Actually, for your information, I don't really like if you get in math a decimals, blah 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 blah, and maybe 6 blah 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 blah. Yeah, probably this is correct. Okay, this is correct. But in my case, I'm usually using a good way of method and numbers, so that the numbers is not really that complicated, so you can follow that easily. So I prefer to be written like this. Okay, it's just preference. Okay, if you feel that this is better, yeah, that's for you. But if it's options, like in the multiple choice, I will give you these options. Okay, so if you get this and you start using this, you need to check this and then whether it's the same as this or not. I think it's the same, similar. All right, we can move on from here, and let me give you another example. And this is just how I build logics step by step, so you can follow the steps efficiently. Okay, because I know some of the educational backgrounds, how you deal with the mathematics and your teachers before. I want to explore that part. Okay, so okay, next questions. Do not use ABC formula. Can you do that? Or you need to use ABC formula every time you see any quadratic functions? Try first. Try first. What can you do besides the ABC formula? Of course, the ABC formula, you get the answers very, very, not very quickly. As long as you need to calculate, you multiply, you divide, you square root, okay, you get the answers. But try, if you are not using any ABC formula, can you solve this? Anyone try? Anyone get the answer? Oh, good, Ardian. Really, really good. Clever. Good. Okay, so probably you are thinking, first you try to see this and this. It's not a good match, right? In the factors. You have -8 and you have +13. You're thinking of +13. When we factor this, there is no other number besides this, right? And this is not a match for an 8. So this is not a good way, right? If you see the factors. So what we can do is, let me write here. First, write the x squared minus 8x. And write the -13 here. Now, if you look here, you get the x squared minus 8x, right? So imagine this is a full quadratic function. What would be if we have this? Let me make this into a little bit right here. What would be if we have the x squared minus 8x? We need to plus something here, and what is that number will be? If I put 16, I can factor it, right? I can factor it, and it will be a we say a perfect factors, perfect square, right? And if we plus 16 here, we need to plus 16 here. So I can do that, right? I can do this thing, right? I need plus the left side and plus the right side, okay? And then this, we can write this, right? Okay. And here we can write 3. And then we are doing the same thing as before. We square root here. And then we get x minus 4 plus minus square root of 3. So we get x is 4 plus square root of 3. And the other x at x2, 4 minus square root of 3. Okay? Do you guys get it, what I'm doing? So these terms here, this plus 16 here, this is usually we call this as a complete square or complete square. Why it's called the complete square? Because it's like a square. So if you have it's x. So let me say this, x plus usually the term is b over 2, okay, and squared. Because when you are squaring this, you will get x squared plus plus bx, because it's 2 multiplied by b over 2, so bx plus b over 2 and then squared. Okay. So if you are having the squared like this, imagine you have the other section here, it's b over 2, then this is b over 2, and like in the square, if you are missing this, imagine this is being removed, you will be missing this, right? So when you are dealing with this x squared minus 8x, actually you are missing this part. That's why you need to add the red color here to make it a full square. That's why it's called complete square. Or y it's over x. Okay, and this is basically 8 over 2 squared, and that's why we get the 16 from here. Okay, and of course, because we add 16 on the left side, we add also 16 on the right. Okay, is it clear? Is it clear? Is my explanation clear? Okay. Okay, good. Okay, let me try one more. I think I would just use another page for explanations. Okay. Let me try. Let's just exercise this. Two plus minus square root of 2. Okay, good. Good, Scarlett. Good, really good. All right. So first, if you look here, we can try to make our path. Okay, so probably you can write this and maybe put aside -6. Okay, because before you try first whether it can be factorized or not, and I think it will be not easily to be factorized, right? So maybe we can group the the left side with 3x squared and minus 12x, and negative 6 in the right side. Okay, and then maybe I'm looking for the I factorized 3, and then I have this x squared minus 4x. If you confuse on if you are maybe having a messy writing in your paper, we can separate this and we can write in another way that this is, if you want to complete the square, we need to plus 4, right? We need to plus 4, and then we get the x minus 2 squared. Okay, and because it's plus 4, so we need to plus this side. Make this. So we need to plus 4 here. So we need to plus 12. Okay. And this is sometimes you making mistakes because it's maybe you're nervous and maybe something happened. You miss out this 3 to be multiplied by 4 and you plus 4 here. And yeah, that's all. One mistake there. Okay. Now we have here, it becomes 6, and I can make out this 3 with 6, and it will be 2. So I will write here x minus 2 squared equal 2. So x minus 2 is, you squared both of them, is plus minus 2. Or you can write x equal 2 plus square root of 2, and the other x is minus. Okay. I think you can divide if you want. Oh, 12? Oh, 12 here. 12 here is from plus 4 here, but it's adding 3 here, right? So I need to add 12. Okay. Okay. If you divide 3 at the beginning, yeah, you can still get, yeah, you can still get the answers. Okay. All right. Let me check what else we have to. Okay, I will just focusing on some equation, some example equation, and how to solve them for today. Okay, the other, yeah, you can use quadratic formula if you want. Okay, but my suggestions is if you find the quadratic formula, like making the calculations terrible, I'm not suggesting I'm not suggesting the quadratic formula, and I believe complete the square sometimes it makes your equations better in your writing. But if you prefer a quadratic formula, I think that's still okay. It's still okay. It's still okay, but I'm not suggesting that. Okay. Okay. So basically, why all this stuff I'm telling you, like the complete the square. So first is if you look at the usually your teachers probably they write this at the very beginning before telling you the quadratic, how to factorize, how to complete the square, how to do the quadratic formula. They are telling you this just this is the basic formula for quadratic, right? Okay. A is not equal 0, where A is not equal 0. Okay, so let's say we have this, and what we are going to do is I will multiply all with 1 over A. Okay, so I will have this become x squared plus b over a x plus c over a. Okay, and then I will move the c over a to the right side. Okay. Now, because you already know we are using the complete the square previously, so let's use the complete the square here. So this will be plus b over 2a squared. This is also plus. Are you still confusing why I'm adding b over 2a? If you see from what we have done here, this is basically b over 2a, right? It's 8 divided by 2 multiplied by 1. So it's actually b over 2a, right? Okay. So I'm adding b over 2a here. All right. And then this will be our squared x plus b over 2a, right? And then on the right side, because it's becoming b squared for a squared, so I can write this as in terms for a squared, and this will be minus 4ac, right? And then plus b squared. Okay. Now take the square root both sides. So x plus b over 2a equal plus minus what you get here, b squared minus 4ac. Square root of 4a squared is 2a. Okay. And then I'm writing x, and then move this to right side, move the b over 2a. So I will write b plus minus. That's when you get the quadratic formula. Okay. So you don't need to memorize it, actually. You need to understand how it came. It came from the completed square like we did previously. That's how you get the quadratic formula. And that's why quadratic formula, mostly they will work because basically all the method, all the solutions, they are the same way, the quadratic method. Okay, you factorize, you make the square, complete the square, quadratic formula, all is actually essentially same. Okay, any questions from here? Any question from here? Okay, so whenever you find or maybe you forget how to make the quadratic formula, first thing is you write this, you divide all by a, divide by a, you get this, and you complete the square. Okay, complete the square. Okay, and then you solve x, solve x. All right. Okay, now one thing that I think also important is this b squared minus 4ac. This is we call the discriminant. What's discriminant for? It's for distinguish whether you have the solutions or not. Of course, if you look at this, it has the square root, right? So whenever you find it's less than 0, meaning there's no real solutions. And probably it will be a complex, right? Okay. If d is equal 0, what has happened? Of course, it's only having one real solution. Because if it is 0, so there will be no plus minus, right? It's just the number in the front, right? So whenever it's 0, this plus minus become not really important. So that's why you have only one real solution. And when you have d greater than 0, you have two distinct real solutions. All right. I think I can do one or two more. Okay, let's move on. Any question here? If you have any questions, just type in your chat box, okay? All right. So basic math, basically, I will explain it like one by one, step by step, really slow at the beginning, but in the middle, later, I will going a little bit faster, okay? This is just to get you more familiar with the math. The whole equation, which one here? And one more thing, if you see any solutions and then you think you understand the solution, you need to try out by yourself without looking any answers. And then if you feel like you try, and when you succeed, then okay, you get the answers, you get the idea behind all those method and steps, okay? Because sometimes when you look at the answer, oh, it's easy, blah blah blah, but when you are doing it yourself, sometimes you are not really understand how it does, okay? Okay. How about if we have the solutions like this? Equations like this, and then you need to find the solution. Solve the equation, meaning you need to find the solution. Probably this will be the last example that I will show you for today, and that will be the last part of our lecture. Nine, x squared minus 9. Wait, maybe I need to change my 9, maybe like that. Usually, if I write g, usually I write g like this, like in your textbook, in your any book that are writing g, or if you write in the Microsoft Words, or maybe in any typing, or maybe in your smartphone, your small g's looks like this, right? Sometimes. But this is 9. This is x squared minus 9. So 3 over x minus 2 over x minus 3 equal negative 12 over x squared minus 9. Okay, what's the answer? Is there any two answer or one answer? One solutions or two solutions? Okay, I will wait for 1 minute more, and then I will solve for you. All right. If you see the equations, you have 3 over x, 2 over x minus 3, minus 12 over x squared minus 9. The thing is, x minus 3, and x squared minus 9 is actually a simple equations, right? Actually a simple equation. But because it's in the fractions, in irrational terms, it becomes a really complicated, a little bit complicated, right? So what you need to do here is basically you don't really want all of this to be here, right? You need to remove this, right? The denominator you need to remove, right? So how can you do that? We need to multiply with something that can remove that, okay? And we need to multiply both sides, left and right. Okay, so we have x minus 3, right? And we have x squared minus 9. If we are multiply this, we get minus 3x. It's not the same, right? So we need to multiply all, at least, right? But we know that x squared minus 9, it's came from x minus 3, x plus 3. It has the same x minus 3. So to remove all of this, we need to multiply the common factor from all of these two. Okay, so we need to multiply with x and x squared minus 9. Okay, because x squared minus 9, if you divide by x minus 3, you will get x plus 3. Okay, so let's try that one. So multiply with x and then x squared minus 9. Right, so this will be canceled. Okay, and this canceling this part, right? And this will canceling this, and then it will make x plus 3. So we'll get 3x squared minus 9, because we still have x squared minus 9. Okay. So yeah, to make it, maybe you'll be confused here. So you basically multiply each one. I think this will be better for your understanding. Okay, so you will get 3 okay, and then you solve this. And solve this and compute. Sorry. And probably you have this answer. And you write, oh, x equal 3, x equal 9, negative 9. Is it correct? It seems correct, but don't forget that our original equation is a fractions. It has certain domain. That x is not 3. So this will be wrong. So the answer is x equal negative 9. Okay, because sometimes you get the answers like after you get the idea that, oh, probably I have this equation here. Oh, easy to factorize. You get x equal 3. You get x equal negative 9. You saw the answers. I give the options 3 and negative 9. You choose that, but it's wrong. The answer is only one solution, which is the x equal negative 9. Where did you get the x and x squared minus 9? It's from the common factor, or not the common factor. You get from here and here and here. What you need to multiply when you need to remove all of them. So first, you need to have the x squared minus 9, right? And second, you need to have x. But do you need the x negative 3? No, because x squared minus 9, it's composed of x negative 3. So it's all here. So by doing this, by multiplying the fraction with x squared minus 9, actually you are already removing all the trouble here. Okay. After removing the denominator here, it's just basic multiplying. So you multiply one by one here. Okay. And then multiply. Okay. Multiply here. And then we get here. And then we just multiply, normal multiply. We get this, this, this. And then we calculate all of the related variables. We get x squared minus 6x and minus 27. And I do it one by one here. And then simplify, become this, and then factorize. Get it? The idea? So basically, this is just a normal computation here for finding the factorizations. All right. I hope you get my point here. And that's the lecture for today, actually. And I need you to, there's no quiz for now. This is just a feedback time for our course. Let me check first. Okay, so please scan QR code and checking in through the QR code. If you need to use the website directly, you can go to menti.com and you enter this code. Okay. Yeah. For hands, after this feedback time, I will show you the QR code. Okay. Okay. 6 students joining. We have more than 6. Where are the others? Cancel negative.
Prof, may I
Yes.
see the solution, Prof, at the previous slide?
Yes.
Just want to write it, Prof.
Which one here?
Yep.
What, Helen? Why didn't cancel the x minus 3? Huh? I don't understand your questions. I think what you mean is why you are not writing like this. Is that your question? Why not writing this? Yeah, because no need. Because x minus 3 is part of x squared minus 9. So if you see the factor here is this, right? Do you get what I mean, Ellen? Okay, so this x squared minus 9. So I'll write, I'm canceling this with x minus 3. I believe you need to look for more closely. Okay, here. So x minus 3. So this is what I'm multiplying, right? And you say that, oh, wait, there's no x minus 3. The fraction results, fraction, which one? Here. Let me go here first for Helen. Okay. X squared minus 9 divided by x minus 3. Can we divide them? Yes. That's why you don't need to have x minus 3 here, because we already have inside this x squared minus 9. Okay. So this is actually x minus 3, x plus 3. And I'm canceling this. So I'm multiplying 2x with x plus 3, which is, you can look here. Okay, do you get my point, Helen? So if you see any fractions like this one, the first thing, I believe it's the first thing you need to, we need to multiply with all, like x minus 3, and then x squared minus 9. But because x minus 3 is inside x minus 9, we don't really need these multiplications. It will make our calculations difficult, right? Okay, Jordan, why we only take -9? Can you put x equal 3 into the equation here? Here. Yes. That's why, Jordan. So basically, we need to have, or we need to thinking about the domain. Okay. Yes, Helen, you need to try by yourself whether you get it or not. Okay. Because if you're thinking just looking the solutions and then you think you can, but if you don't really know when you understand or not, if you're not doing all of those things. Okay. All right. Now going to the feedback time. I don't know why, but there's only 7 students in my in here. Where's the other? Yeah, we have 7 students only for this the feedback. It's only a feedback, and the meeting shows 11. So there's 4 students missing. Not sure who, but I believe all the students that are on the chat box are the ones who are active. It seems not really important, but I've accounted all the participations from the students. Okay. Okay, let's just start. I don't know where's the other 4. Okay, you just to give me some scale for the course. 5 is satisfied, 1 is dissatisfied. So it's like a skull bear. Okay, I think that's it. 7 students. Yeah. Okay. See you again next week. Sometimes it's very hot in Taiwan. If you're already in Taiwan, if you haven't been here, yeah, please wait a little bit patiently, and see you on Taiwan. And yeah, see you again in the class next week. Okay. Okay. See you again.
Thank you, sir.
Yeah. You're welcome. You're welcome. Yeah, bye. Yeah, I will share the QR code. Wait. Okay. Okay, you can scan hands. Okay. Okay, see you again next week for basic math.